Hey, welcome back. Let's go ahead and try to tie together the two natures of light, particle and wave, using emission, line, spectrum. Okay, so I have a little diagram here. First of all, we look and see this first thing is hydrogen gas. It's being excited by electricity and it begins to glow. As it glows, we're going to try to get a single beam out of it. So we have a slit here so that only some of the light passes through. This beam then hits a prism, and that prism separates the light into 4 different colors: purple, blue, green, and red. These represent the 4 distinct wavelengths that are being seen. This pattern here is the emission spectrum for hydrogen. Every element has a unique spectrum. It's kind of like having a fingerprint. So what causes these lines to be formed? We have a nucleus and we have an atom here, okay? And the light that is given off is from an excitation, so we have some photons of energy going into it. In this case, it'd be hydrogen, so the electricity is putting photons into the hydrogen. It excites the electron. Okay, so it's now at a higher level. This first level was its ground state. This next level is called its excited state. But it can't stay excited for very long. So it's going to drop back down. When it drops back down, it's going to give off energy. Okay, which eventually we know will equal a wavelength. And that wavelength, if it's within the spectrum, will equal a color, especially in the case of hydrogen. Now, some wavelengths don't have color. IR, UV, many of the other wavelengths we can't see with the human eye, but some of them can. And so you can see that in hydrogen, several of those were actually colors. And hydrogen doesn't have any other ones, so it produces mostly colors that we can see. Okay, so now we get the idea that electrons occupy different orbitals. They have orbitals and they have higher orbitals, and they can occupy different levels. And we get this from the emission line spectrum. See you next time. Bye-bye.